for the next lab. It's, presumably by early next week, people will be done with this one. We're going to rebuild the kernel under SUSE. So I'm going to look in a bit of detail in chapter 13 of our textbook. Do you remember our textbook? And that will show you a little bit about what's going on with kernel builds. And then there's quite specific instructions in lab 8 itself. And then lab 9 will fiddle with grow some and customize things even more. All right. Okay, so to give you a little more CSH type syntax, GCSH type syntax, I figured we'd look at your CSHRC file that you have. Now again, there's one from Rohan with one particular path, and we need a slightly different path on our other machine. We don't really have an offload bin on your Mint machines. All right, so this particular file here is something that gets executed when you log on, or indeed any time that you start up a new shell. And the order in which things happen is probably not what you'd expect, right? When you first log on, you figure the first thing that should be looked at is .login. And as it turns out, it's just about the last startup file that actually happens. Okay? So for a Linux system like Mint here, basically it does this stuff. And this is where the system administrator would put any particular things that they want to have happen on their particular machines. Right? For example, under Solaris, opt local bin is not where binaries are normally stored, but Ron Nash has put some things into that directory. So he has set up in here by default that you would get some of those directories as well. All right, so it does the global definitions first, and he has a default UMask value, for example, for people, which you can then change, because after the global definitions run, then your particular definitions run. Okay? So you can change what the UMask is, no matter what the system administrator recommended for you. You get a chance to automatically make it different from that. All right, now those are the two things that happen whenever you fire up a new shell. Right? If you were running bash and type TCSH next to get a TCSH shell, well, then it would run these two guys for you. But if it's a login shell, right, if you do either SU with a dash in somebody's username, or you're just SSHing over to a host, it does these two guys, and then there's a global login file here. Under Linux, and again, it's a little bit different under Solaris, where we have some login definitions. And typically, that's where you'd set up your environment variables. Your shell has its own local variables that it can look at, and different shells can have different copies of those local variables. But also, you can have some what are essentially global variables in that they get inherited by any children that your shell creates. So those are guys we don't really have to keep redefining over and over again. We can just do them once, and then everybody knows about those values. And we'll look at the ramifications of some of those things in a bit. All right, so things the system administrator wants to have set up for you for TCSH and CSH would go into that file. And then you can have your own version in your home directory to make whatever changes you want in overriding some of these values. And we've gone a little bit step further by allowing your CSHRC file to sort of be generic over a whole bunch of different machines. Right? We have one guy, and here's where I typically put all of my basic definitions of things, aliases and things I want to have for every single machine. And then, as we saw at the very bottom of this file, we can make adjustments based on what our machine name happens to be. Right? At the very end, you've already messed with this. If there's a file called //.eris CSHRC, well, go ahead and source that file and maybe change some things, because eris may have some things that are different than what you have on your Mint machine or what you've got on Rohan. All right, so we sort of added to this list a little bit further. All right, now under Solaris, they do things a little bit differently. There's a global.login file, and that one's first. right? And then you get to your own thing. So they sort of combined this guy and this guy under Solaris into one big file. And other flavors of Unix do things differently. The old BSDI did it in this particular way. Okay, which again is not too different from this, except notice the two system ones happen and then your two local ones happen, right? So the order of these two guys got changed. All right. Now, as it turns out, you can have different things happening for CSH than for TCSH. TCSH pays attention to a .tch HRC file, if you've got one in your directory. Otherwise, it just uses the CSHRC file. And it also pays attention to the ~/.login, and also a thing called CSH dears. So you can have, as we'll see, a stack of different directories to get to, which unless you're typing out long, tedious path names, you generally probably don't use very much, but I often have 4 or 5 of these things piled up in the tasks that I'm doing. It makes it a lot easier to switch to places without having to type tedious path names over and over again to move to a different directory. So it makes the CD things a lot easier to mess with. All right, now in these scripts, you generally don't want anything that's going to give you output. So putting in echo statements and things in there tends to break some utility. So it's generally not a good idea to do that. All right, and what we did for the 470 class here, if you go to a regular Rohan account and type mount, probably nothing's going to happen because that's a system administrator command, and most people don't care what's mounted where as regular users. But if you type /sbin/mount, you can see what it is. And regular users can get a report of what's mounted. They can't change what's mounted, but they could get a report out of that. So among the things that we did here is we redefined what our path was, just so that you, even as a regular user, could see some of the system commands. So that's where like VIPW lives. And you can't use it as a regular user, but you can at least find it in your path if you need it. So, new use for parentheses here. We've already seen them used in, say, a for each statement, or in a while statement, or an if statement. Right? They blocked off portions of text. Here we're seeing it being used to create an array of entries. So you can define a variable name. Again, that's the set, as we've seen in the CSH examples we looked at last time or the time before that. And if you want it to be just one item, you just list that item there. But if you want it to be an array, you use parentheses to create that array. And in this case, we're going to take the existing path and add some stuff in front of it and some other stuff behind it. So let's do an echo $path, for example. And here I haven't run the one we have seen before, but basically what's going to happen up there, we're going to say set path equal to parentheses /bin, and all 9 of these guys, plus I put some other stuff behind it. And so we get maybe 12 entries or so out of that. So you can base the new path on the current path that you've got. So that's what's happening here. And in this file here, even though it's a little bit dangerous, right, we're also giving you dot is in your path. And we explained that beforehand, how your system administrator, perhaps one of your users might trick you into running a command that you didn't intend to run. It's relatively safe to have that if you've got it at the very end of your path. Because then unless you mistype a command, you're going to get the real one that you have. So if we do something like the ls command, well, it'll first see if there's an sbin ls, and then it would be what, op local bin ls that it would look for next. And as soon as it finds a command called ls, that's the one you get, right? The one highest up on your path. So if this guy's at the very end, you only look in the current directory if all else fails.
Yeah. So set path that basically makes a variable that is available in the entire shell session.
Correct. Right. So we've got that, and there are various things that pay attention to it, like the execvp command, etc. It cares about your path. Right, there was our path, right? And so we have, I can echo $path sub 3, for example, to find one of the many entries that are on that path. That was the third one that was listed currently. So all that stuff is available, and whenever your shell tries to run anything, it pays attention to your path. And when you say ls, that's how it figures out who you would get. Now, if you want to find out what it's doing, we could do a which on the ls command and find out that this is what it does. It does ls with the -- color option. And you may recall that gives you these nice little colors here. Executable files on Rohan come up in green, directories come up in dark blue, soft links come up in light blue, and so on. All right, let's try another one. Let's do a which more. And this will tell you, it was user bin where it first found it. It looked here, there was no more command. Look there, no more. Look there, more didn't exist, but it found it here. So even if there's a more somewhere further down the line, that's the one it's going to point to. Okay. All right. Now next, we try to figure out who we are. For our purposes here, don't really need this in a regular type account, but we want to find out are we root or not. So we can do that ID command, and we recall what that does. ID, and you get all this stuff here. And in particular, we want to pull out our user ID and find out whether it's 0 or not. Let's see what's happening here to try to grab that information. Now, the tricks that you find in this file, some of these things you might find actually useful in writing your shell script. It's not for every one of the projects I've given out, but for several of them, you may want to use these things. We're going to use the sed command here. And you can either just say sed and give it one substitution pattern, and that's it, or you can use the -e option and tell it to do several things. And you don't have to pipe it through 3 or 4 different sed commands. A single sed can do a whole bunch of editing commands for you. Now, it's similar syntax to what you could type into VI. Right? If you do a colon, the colon command in VI, it takes you to the bottom line of the screen. And you can just tell it, hey, substitute UID equal for, in this case, the empty pattern. So the same sort of commands that you can use in VI are available in sed. That stands for stream editor. It's going to take output coming from standard input, essentially. Output from this command is going into the input of this thing, and line by line, it's going to make these changes to it. And the first thing we're going to do is knock off the UID equals part of that ID command that we've seen. And then what we're going to do is get rid of pretty much everything else. We're going to match an actual comma, and then dot matches any single character. And we're going to take 0 or more of those single characters, and star is greedy. It'll take as many as it can, and that means everything from this parenthesis, the first parenthesis it finds, all the way up to the end of the line, and get rid of that stuff too. So the result, actually just if I do that, I can now echo what $my ID is, and we get the 6573. And we can see how that happened. And it took this line here, I told it, find the first occurrence of UID equals, and make that go away, replace it by nothing. And then find everything from the first parenthesis to, in this case, the end of the line, and make all those guys go away. And that leaves those 4 characters, which is our UID. And that's in a variable, my ID. All right. So again, looking over this, actually, let's just count. Going back quite so far. I know more.
So the whole thing is basically just a shell script?
Yeah, so this CSHRC file is essentially a shell script, the shell script that runs every time you fire up a new shell.
Okay.
So every single time it figures out what's in my ID. So you go on any of your machines here, type in echo $my ID, and it should tell you your user ID essentially at that point, because this line ran in every one of those shells that we've got. All right, so here now we make a test, another if. Look up that value, see whether it's different from 0. And if we were going to do it really well, we probably should have double quotes around that, and maybe have an X in front of it. But we know how the ID command works here. I'm not going to have something with a bunch of spaces in it, and it's not going to be an empty string. It's not going to begin with a dash. So I didn't bother to put those extra safety features. But especially when you're talking about random stuff that might be coming in, you really want to protect it as we had done on page 40, whatever, to do this. So this is a simplified version of what I showed you how to safely test IDs. So here we check if we're not root. Let our UMass be 006. Keep things relatively private. Don't let the rest of the world read and write this stuff. But otherwise, if we are root, then set our UMass to 022. So we let everybody do everything except no one in the group can write and no one in the rest of the universe can write. When I create new files, they're readable and executable by everybody. But they're writable only by us because of this UMass that we put. So we get privacy when we are supposed to have it, and when we don't have root doing weird things and making files that people ought to be able to read but can't see. Now the uname command will tell you the operating system that you're on. I believe we get Solaris on Rohan. We get like Linux or something if you're over on Eros. And so we can run uname. Now uname-a, I think we put that in as the top line of your etcmotd file. And that tells you what version of the kernel you're running and all sorts of other stuff. The -a is a -all option. Tell you everything about it. But just plain old uname will tell you just that one fact that it's Linux or something like that. So assign that to a variable. Okay. Now notice these guys here and these guys here are back quotes. Somewhat easy to see the difference here. Right? There's a regular single quote, just down below the double quote guy. That guy is the guy probably on the tilde key here, the back quote. So notice what happened here. If you run this thing here, it would give you 6972 or whatever it was that came up. But the back quote here says, don't set my ID to be all these characters. It says, run this command, look at the output, and pretend that's what I typed here. So we wound up doing set my ID equals, and then those characters that came out of this command. So you can use back quotes to good use. Same sort of thing happened here. Looked up what's going into this OS is not UNAME, but it's the result that you get from running that command. And so if it was SunOS, then you have to change things a particular way with what you're doing anymore here. And you might even want to change your CD path. We haven't talked about what that is yet, but we'll see how that works later on under some situations. Now, when we get more into the networking end of things, I get tired of typing /nr or ifconfig-a, etc., over and over again. So I give you guys some aliases for that. These are the ones that I use. I just type nsnr, and it pretends that I typed all of that stuff. Now, by the way, you can see what that does. And this gives you your routing tables. We haven't talked much about this yet, but just to give you an idea of what's actually going on. Right? It says that, hey, if you're in any of these particular subnets, an address that starts with 192.168.3. something or other, then this is where we're going to send things next. And if you're on that subnet, then you send it to that particular guy. And we also have a default thing here. If you don't fit any of these other descriptions, then send it out to the campus backbone, which is this particular guy. In general, on our campus here, all of the routers for any given subnet have a .254 address. So the addresses go from 1 to 254. 255 means something special, and 0 also means something special. It means it's a subnet. Now, we haven't even begun to talk about those things yet, but just to give you a little idea of what this table is about, that's the sort of thing you might need to use when you're trying to deal with network issues and trying to debug those. So you might try an SNR on your NIF machine, for example. And it should say, hey, the default is send it over to Legacy. And that might be actually all that it puts in there independently. All right. If config-a, that's interface configuration, tell me about all of them, essentially. And often that's going to run off the screen, so I type the results through more. So when I type those 3 characters, it pretends I've typed all of those characters. And then you can find out which interfaces are up, who they're connected to. An interesting place to do that might be on Legolas. Try that command on Legolas, because there is 2 interfaces there. One of them goes to a little router box that's connected to all of your machines. That's the 10.0.0 network. And the other one is 130.191.28 something or other, which is .154. It's the router for a portion of that building, which will send you to the outside world of program. So you go out one of those 2 interfaces there. And of course, it also lists the local loop interface, 127.0.0.1. Right? That means don't really go out on the network, just take it off any packet off of the outgoing stack and put it back on the incoming stack. It's what we're coming in. All right, I think earlier we talked about these aliases. Again, don't count on these on any bare Unix account. You probably don't have them. So we use the -I inquire option for move, just so that students don't inadvertently throw away files. We can try to move one file to a new destination, and that new destination is already there. The default behavior for move is to just blow away the other file silently and replace it by your new file. If we do move with the -inquire option here, it warns you, hey, there's a file already there. Do you really want to blow it away? You get a chance to send nothing. And otherwise, it just disappears without you actually knowing about it. Similar to the cp command, it'll also destroy files without the -I option. And the -P option is preserve the date. So when you copy a file, it doesn't get the date of right now when you did the copy, but it copies the date that was on the old file, as though this new copy is just as old as the old one. And that's usually useful for keeping track of, of when things were created. So just copying it or moving it doesn't destroy it. Well, obviously, move doesn't destroy it because we haven't changed the date of the file. All right. All right, we can look for zombies on the system with the UFO command here. And that does a PS of looking at every single thing that everybody owns here. And we're looking for things that are defunct, essentially. That's the word Solaris, at any rate, uses for the zombie processes. All right, so let's look at what a PS... which PS? There's different versions of PS. There's a System 5 one and a Solaris one, and I'm not getting the right one. All right, let's also we'll do it. Figuring out where the other PS is. Let me see if the UFO actually works here. Alright, so there's a list of everything that's run. Every single user, every single process that they have. The WW option says normally it would cut it off right here at column 8. But you can see much, much longer lines like what we see in there if you use WW. single W cuts it off at size 132, 2W lets it go on forever. Right, so we're looking for the word defunct somewhere in there. Right, so that's what that was about. All right, now, what's this stuff about these parentheses around here? Well, grep also understands regular expressions. You don't have to look for one particular pattern. You can have it look for wildcards and things like that. So DE asterisk UN would look for DE, 0 or more characters followed by a UN. In square brackets, normally you list a whole bunch of different things in there. So FGH, it says that this third character would either be an F or a G or an H. We can look at several different things. If we do this, though, then what shows up in the grep command are all 7 of those characters, but it's looking for just the 5 characters, DEFUN. If you just put DEFUN there, it would always find this grep command as one of the things that mostly works. If you do it this way, then it doesn't see that because that's not DEFUN. It's a slightly different pattern, even though it winds up identifying the exact thing that you want. So that's how you find zombies, for example. All right, a couple of other commands here. The ttar command here just makes it a little easier to keep you from having to type this big long pattern here. So the tar command, the -t option says, hey, give me the titles out of this tbar guy. And tell me about them verbosely, which is kind of redundant in this case because we're already asking for the titles, and verbosely just sort of tells you the names of each file. The Z here says, hey, this is probably a compressed file, so uncompress it first before you try to do this. And the F says, use this next pattern here to be the name of the file you want to look at. Let's maybe create one here and see how this works. Actually, I'll create it using an xtar command, and I'll call it mytar.tgz. It's a GNU zipped tar file. And what I'm going to put in it is csh.start, all of those guys. Alright, so we do tar-xvpzf, P is preserved dates there. I could tell it to create a file called mytar.tgz. Right? And then what do we put in it? All the guys that begin with the CSH. Let's see if it's happy with oh, I got it.
Don't you want C, B, P?
Oh, yes, I'm creating, not extracting. Okay. All right, so let's replace the stupid X with a C. Thank you. All right, good. So let's create a guy here, which I don't have any others for the creation. So this says create a new guy with that name. And then you give it a list of things you want to put in there. And those could be directories, and it'll give you that directory and absolutely everything down below that directory as far down as the tree goes. And because we asked for the V option, it's telling me which things are going into the file. So if we look at what we've got here, actually let's do an ls-l, and we can see the relatively big file there because it's got all of those characters, all of those characters, all of those, all of those, and all of those. And that's, what, 10,000 characters or so? And yet because we compressed it, it's only about half that size. So it looks for common things that it can shorten. Like there's a whole bunch of places in these files where it says set space equals space, and it just takes a different pattern for that, and it uses just one character to represent all of those. And it's got a little table about how it's going to expand it. Hey, you see this particular character expanded out into this big long expression. And so we get some compression out of this. All right, so now I've got something we can try this. If I do the ttar guy on that and give it the mytar guy, it'll tell me about those particular types. So these are the 5 things that wound up into that file that we looked at. And their appropriate sizes, etc., and when they happen to have been created, and so forth. All right, now let's see if we can figure out what these exclamation things are. Okay, I think you're familiar with, because I've used it several times here, when I do exclamation point $sign here, that means take the last parameter from the previous line. So often I type out something with some big expression at the end, and I want to reuse that thing, and just say $sign and $sign to find the last one. But you can also get any particular one you want. In particular, you can say, hey, give me number 1 term, or number 2 if there were that many parameters on it. Like the 0th one is the name of the command, 1 is the second thing on the file. So back here when I typed ttar mytar.tgz, that exclamation point, :1 thing turned out to be that name. It was that name on this particular line here. Okay, so that's what bang bang : 1 essentially does for us. Give me argument 1 of the previous line. Well, why don't I have backslashes in front of those colons? Well, because exclamation point actually means something. Even when it's in single quotes or within double quotes, exclamation point means, repeat some previous command. And I really didn't want it to do that. I wanted the xstar alias to have actual exclamation points in it. So, indeed, if we ask for that, alias xstar, you see that there really are 2 exclamation points in it. If I didn't have those backslashes there when I created the alias, it would have tried to run this further command here and then put :1 on the end of it, which is nowhere near what I wanted it to do. All right. Okay. And let's see, actually that's an old alias because RCP is shut down. It's an insecure protocol. We want to use SCP, the secure copy command, not the old remote copy command. So I probably should just take that out of the files here. Similar, we don't really care much about this. This alias is interesting here though, the V alias here. That repeats the previous VI command. And again, I need the backslash in front of that so that it does an actual exclamation point VI. Find in your history the last time you typed VI as a command name and run that again. And when you get done with it all, then report what it was. Let's see if that works. So if I type a V, for example, it's trying to do a VI on sig handler, essentially, which doesn't exist in this directory anymore. I'm just going to get out of that. But when we're done, it will tell you, hey, this is the last thing that we have done, VI-R of sig handler. So, and I use that all the time, essentially, because often I'm editing a file, doing something, and I want to edit the same file again. And I don't want to type out all of that. I'm too lazy to even type exclamation point V. I just type V, and you get that result. All right. And again, here it was important to have the backslash. Otherwise, the alias itself would have had that hardwired last VI that you had ever done, right? Rather than your most recent one later on, which is okay, and you can do a capital V here, and that'll do a VI on the last word of the last command that you had typed. So maybe you did something or other where you catted a given file, capital V then was VI, that particular name that you had, last word on the previous line. Okay, and just for fun, we can look at this thing here. Let's say you've messed up a given file, given command, the previous command here. We can echo that previous command, put that into a uniquely named file in /temp, let you edit that file with the previous command on it if you need to do lots of changes to it. Right? So you could go in with VI and change things around, get the command you meant to type right. Okay? And then when you exit VI, it'll source your newly changed file. And then after it's run that command for you, it removes that thing and gets it out of 10. Now, what's the dollar sign thing that we have here? That is basically your shell ID. If we echo dollar sign, we get that. And notice that is the PID of your shell. So you could do that, but then if somebody else had a similar alias, you might have two people trying to write to the same file. So this puts more or less random but relatively unique characters on the end of CMD to make sure that there aren't any name conflicts. Or you might have two different shells running, and you're trying to use this oops command in two different ones. And as long as it's two different shells, you get two different numbers being reported, and therefore have two unique file names there. All right, so that's also something you can do with that. Notice I've given you an H alias here. Right? History tells you what you've been running here. Let's do a history, and we'll see a ton of commands here. Now, notice a lot of stuff went by on the screen. We saw the earliest commands all the way down to the very last thing that I had typed. But H presents things to you a little bit nicer. It does history with the -R option, reverse them. Tell me this one first, then that one, that one. But again, don't let them all scroll by the screen. You type through more, so you see one screen's worth, and probably what you want is there. You can just quit out of more, but if not, go on and look at your next page of stuff, and your next page of stuff, and so on. And by the way, there was that previous VI command that we had done when I got with the V option. That was the first thing it found on this list that began with VI. So that's the one that ran. Okay. All right, so hopefully these little things that we're looking at tells you a little bit more about how to easily use your shell, but also give you some ideas of what you might be able to do to make your shell assignment work for assignment 1. All right, so here's a fancy version of GCC that you could use. And since we're not really doing much compiling here, we compile CTWM, but that's about all we did mess with the compiler. This will run the compiler for you using the -G option, so you can use EVX if you needed to. It'll create an output file based on the name that you had given it. And it will take error messages and send them into a temporary file called temp error, again with some gibberish on the end of that to make it unique. And then it'll grep through that particular file for things that you want to have and make it look a little bit nicer and write it over this common errors file in your current directory. And then get rid of that temporary one that it had out there. And then we'll see, hey, if this guy that we just wrote out is 0 length, fine. But if it's not 0 length, then use your favorite editor. For me, that's VI here. And look at those error files. And we're running VI on 2 different files, that one and your original source file. So you can look at your errors, and then with :E or :N to go to the next file, fiddle around with your source code for a moment, and then :E will take you back to the errors if you want to review them again, and then another :E will take you back to the other file. So you can look at both things at the same time. Nowadays, it's probably easier to just put 2 SSH screens up on the window and have one of them where you're looking at the errors and the other one where you're editing your file. But this was kind of a useful thing to have back in the dark ages when you had one tube in front of you and you could only log onto your machine once. Okay. Let's see. Now, these were mostly for illustrative purposes. We probably don't want to go through that, but let's see where your prompt and things have come from. Now, there are times when we want to just get out of this file. If we're not running a shell script, if it's an interactive session, then I'm going to define some more stuff. But if it's a shell script, it's time to pretty much get out, and we'll exit. So we check to see whether a prompt has been set. This little thing that gives you the %sign value. Actually, let's see what it really is on Rogan. Let's echo $sign prompt. What? Dollar sign. Prompt. Okay. There's our actual prompt. And that we get. Now, by the way, why did it say that there was no match? Because that's an exclamation point. It looked for a command that began with a closing square bracket and couldn't find it. So I managed to protect that by putting these guys in double quotes here, and we can print out what it was. Now what your prompt does here, it says, hey, turn on boldface. Well, you can't see it very well on the screen here, but that's actually a different color than the rest of this command. Turn on boldface, type out Rohan, and then turn boldface back off. And then we're going to take our path here. Print out the path. In this case, it's just tilde. And normally what you'd get is your entire path. So if you were in user local lib bin something or other, that would sort of march halfway across the screen. We set it up in TCSH to, at most give me two subdirectories worth of stuff here. So let's see what happens. If we cd to user local. Right, that's what I see. If I go down to bin, though, it doesn't tell me user local bin. If it's 6 directories deep, it's not going to show me 6. It's going to show just the last 2. So bin by itself, there's 20 different places you might be. Right? But this gives you a little better idea of where you are without, using up your entire command. Right? So that's what the %C2 is. And now this thing, the exclamation point, using yet another way in the shell, says, hey, take the command line number, whatever it is, and put that in. Those are the numbers we were getting out of the history command up here. Right? Command number 65, 66, etc. Whatever it is, show me what number that is in the shell. So I could go back here and do bang 113, for example, and repeat command 113. So if you scroll back in your history and find out what it is, if I did a bang 65, I get this VI command. Let's do the bang 61. Should have been a sleep 30, and yes, I believe it is. Sleep 30. All right, so that's another way to do that. You can do it by giving the pattern of the first part of the word, or you can give it a command number to work with. Now, by the way, you can't give it a pattern that's like CD space B in here, because the shell doesn't keep track of a big long line like this as one big text. It really tracks individual words one after the other. If you're already taking the 570 course, you know about that in the new RV. Right? So it only looks at new RV sub 0. It can't really look further.
What's it sleep 30?
It's, well, kind of what it did here. It freezes your screen for 30 seconds.
So it freezes like the shell?
Correct. So sometimes you're issuing some command and it might, maybe it's in the background or whatever, you want to wait a while before something happens. You can do sleeps on your own. There is, in a C program, sleep parenthesis, and you can put in, I don't know, a number of microseconds or something, milliseconds, I think, inside the parentheses to get it to stop for a little while.
So does the shell still interpret things during that time, or is it just...
No, it's sort of waiting. Now, if you have a background job, it's probably working on that background job, but it just won't give you a prompt back until 30 seconds have passed.
Okay.
So that's what that is. All right, so get out if we're not if we have a non-interactive shell. If we've got a prompt here, and it's not a shell script that's being run, then maybe these other aliases and things that come next could be useful. Now, I set things up so that we have a percent space as that's these two guys here, as we'll see a little bit later on down, with no prefix in front of it or anything like that. But if we're root, you may have noticed your root shell has some pound signs at the beginning and more than one pound sign at the end here, so that you are a little bit more cognizant that you really are root, and you have to be careful what you type. So this is basically what sets that up. Okay. All right. Right, so we'll do some things if we're root, some things if we're not. LS with the -A option Normally dash lowercase a will show you all the files you have, including the ones that begin with a dot. But that includes plain old dot and dot dot, which you sort of already know are there. Right? So with the dash capital A option, it gives you all the dot files except the two that you already know are there. It won't show you the dot and the dot dot. So ls as a when you're root gives you that nice behavior. Okay. Now we're setting a few things in here. First of them is file completion. You can type the beginning of the path name, right? We've seen this, and if you hit tab, it'll try to complete the name if it's unique. Otherwise, it'll complete as much as it can until there's a choice that a human's going to have to make by typing an extra character. That's the thing that does it. We depended on that in a couple of places in the lab to be able to quickly type out these path names. Now, the no clobber thing is for when you use the greater than sign to create a new file. Right? Send the output into a new file. This tells it that, hey, if that file already exists, don't write over it, refuse to write over it. And now you can get around that with greater than exclamation point. Yet another use for the exclamation point symbol in the shell. Let's try that. Let's look at let's go back home before we try that. All right, so let's do an ls and try to overwrite a dot out. You get this behavior here, and it doesn't overwrite a dot out. A dot out is still that binding. But instead of saying greater than, if you want to do overwrite limits, you do, let's just replace greater than with greater than exclamation point. And now it really will overwrite it and not complain. So greater than exclamation overrides no clobber if it's set. So that's kind of the best of both worlds. You don't inadvertently kill a file. Well, if you don't have that alias in there, you will inadvertently kill files with greater than. So keep that in mind if you're in a bare bones account somewhere. Greater than is dangerous. You can wipe stuff out. But once you have these aliases, it at least tells you you're about to wipe it out. And it's quite easy then to fix that up. Just go back and replace plain old greater than with greater than exclamation point, and it really will do that. Right? So if we cat the a.out file, it really does have the output of the ls. Okay. All right, so that's what no clobber does. So ignore end of file. Typically, when you type a control D at a process, when you're giving input to the sort command or the sed command or whatever, you do control D, that says, hey, that's end of file, and now the process ends. That's the way your shell actually behaves. Right? It listens to you type until it gets an end of file signal. So if you inadvertently hit a control D in the shell, you can get logged out. That's generally not behavior you would like, so it is possible to set up the shell to ignore end of file. Control D as much as you want at that prompt, and it doesn't do anything. Well, it says type exit or type log out to leave the shell. So it keeps you from rather annoyingly getting logged off unexpectedly. And notify is the thing that will tell you about when background processes complete. Let's do another one of those sleeps here. We'll sleep for 10 seconds. And we'll do something like an ls. Job, actually, I can do a ps as well. You probably have time to see it. There's that sleep process going. It did tell me that this is the process number that was happening. And what notify does is exactly this that you just saw here. When a background process is finished, it tells you about it. Sleep 10 just exited. That can be useful if you're doing a compilation with something other in the background and redirecting the output into a file. You don't really know when it's done. You will get notifications here. So that's what notify is. That's all useful options to set on your shell. As you can probably imagine, that CCSH and CSH are tens of thousands of lines long because there's all these different things you can do, and every one of them has to be programmed in, and more than that, they have to not screw each other up, right? You have all these fancy options, and it's easy to imagine two options, interacting badly with each other. All right. All right, now you can also save a part of your history. Our history goes back 352 commands. I don't think we typed 352 into the shell just yet. We're at 100 and something or other here. Right? And when you log off, it saves the last 176. Those are numbers you could adjust. The next time you log on, you get to see what you have been doing the last time. So bang D probably still does something to you. It'll repeat the last VI command. That's not as useful these days when you can be logged on from 7 different places. The last place you logged off of is the one that sets up your .history file, and that's the one that gets loaded next time around. So you may not get the right thing. Back in the day when there was only one little screen in front of you, it was easy to pick up wherever you had left off with these commands. So it's still kind of a relic from them, and sometimes you may find it useful. All right. Now we'll do a bind key command here, and whatever the output of that is, just throw it away. And we're going to put it into the bin bucket. And we'll see whether this thing makes any sense or not. Now in CSH, there is no command, built-in command called bind key, and you get an error message out of that. In TCSH, this thing does not give you an error. So you can look at the status of the previous command, find out whether there was an error or not. And this is an easy way to tell whether you're running TCSH or CSH. You can set different prompts in different situations. Right? So CSH doesn't have anywhere near the flexibility that TCSH does. So I've got an if and then an else to change some of these commands. So I'm not sure we'll look at the TCSH ones, the CSH ones, but let's see what happens with TCSH. Now, when you print out your history in TCSH, it tells you the time that you issued those commands. And I think we saw that before. Let's do the H guy. So you can have some idea when you were doing things there. And every now and then I find that useful. It was about 7 o'clock when I was doing things, so I can look at that section of the thing. And the AM PM thing that we're about to see here, you can either do it on a 24-hour clock or a 12-hour clock, and it'll tell you AM and PM instead. And now we do some auto-correction things here. If I, let's type my favorite word more. If I do MROE of something or other, it makes a guess as to what I meant to say. Now, if you screw this up too badly, you can't guess. Sometimes the guess is wrong. But if you can find that by adding just one more character, it can make sense of it, something along the path. Or if by interchanging two characters, transposing the two characters, it can make sense of it. It'll ask you about that. So that's what the autocorrect thing is. There's a way to do that with file names as well, but I found that to be less than useless, because sometimes you really want a new file with a name slightly different than what the old one was, and the shell really wants to make it match the old thing. So I don't turn that feature on. Okay, and auto expand here, I think that's what lets you do the Control D to see all of your choices there. I actually forget what that was. Okay, and we do give it this little feature here about how you try to correct what your changes are. All right, and now it'll also beep at you a little bit if you don't have when you do try to type the tab to do things here, it'll beep at you if there's more than one choice. So if you're alerted that that's not really the end of a legal file name, you have to go a little bit further. There's a few other things like that. You can do the CGWM and look up all of these options if you want, but we're running out of time, so I'm going to kind of move ahead. All right. Now they use Emacs type editing here, but you can't get VI style editing if you grab it. Right? Where in X, you can get rid of certain characters and you can move ahead a word, etc. They use Emacs-like commands here. And the one we kind of want to change here is the Control W here. If you type a Control W, it erases an entire word. It will delete not just one character, but a whole word. Because otherwise the word erase is kind of inconvenient for it's using the default commands. All right, now here is where we actually created that prompt that we had seen before. I'm just going to put a prefix on it, look up what that is, which was either nothing or those 2 pound signs that will help you remember really our root. And then it'll go in standout mode, tell you about the host, essentially. Right? You want to set you up as a host. So we're getting a little different prompt than what I've seen here. I didn't source this CS470 file, because we're over here on Rohan. Right, but that's something that would look up something like Rohan. Only in this case it would be in standout mode rather than just boldface mode like we had a moment ago. And then we do a similar thing with the %C2 here. We do a portion of your path to help you figure out where you are. And there's different ways that you can do these history numbers. Notice they don't use, TCSH doesn't use that bang thing like CSH does. They use %H to look up your history. And our suffix is either a % and a space, if you're a regular user, or earlier we set it up to 2 pound signs and a space if you're really going to help draw your attention to who you are. All right, let's see. Probably don't have to mess with that too much. There is something we do each time that we change directories here. Each time we have a new current working directory, we can tell it to do some things here. In particular, we can set this variable called dears, which we'll use in a moment. And it can, how you do your posters and things like that. All right, so let's see. I'm going to look up $sign dears. Oh, that's right, I didn't source this one on this one. All right, so, well, I'll just explain what it actually does. But if you were on an extern or something like that, what's going to happen here is it's actually going to change the title bar here as you go into different places. And in particular, it's going to print out the entire path there. You may have already noticed that on your machine. And so it is really user local lib bin something or other. You get to see that entire path up at the top. There's a little prompt here on the screen. You only see a little bit of that. So we get sort of the best of both worlds there. You can figure out exactly where you are by looking up at the top of the machine. We also print the name of the host up there as well. All right. Now, whenever we do a CD, we actually do several things. CHDIR is the same thing as CD, but I want to redefine what CD means. What I do is I remember where I am right now, and then go to wherever you just told it to go to. And then run this set banner command here, if necessary. We set it up so that it changes the banner. All right, and then we have push and pop using push D and pop D. Let's look at how those guys actually work here. If I do a dears command here, just have my home directory on here. I can do a push D of etc, essentially. And now I have 2 things on the directory stack, etc and tilde. And push D will flip them around, flip the top 2 entries. Another push D of /temp. Now I got 3 things on the directory. And the guy at the head of the list is the one that we've got. And once again, push D will flip the top 2 guys. So etc is still 3rd on the list, but the top 2 guys are in different places. So this makes it easy to go into different places. You can use push D and pop D. And you don't even have to type that much. If I just do a PU, it does a push D, but it also adjusts your banners and things like that. And the pop D command removes the top level and then takes you back to the next level. So that part works just like a stack. Right? Stacks aren't really supposed to allow you to do that, but this thing does. And actually, let me put that back on. Well, actually, let's look at the back command. That's another one of the ones that we have here. That takes you to where you were a moment ago. We had been at temp, and went to tilde. Now it says go back to that. And another back would take you back to the other one itself. So that's one of the aliases that we have here. That's why we remember each time we make a change what the old directory was, so that you can go back to it if you wish. All right, let's do push of a tilde, and we'll push an S bin here. Right? And now I've got these 4 guys on the list. I can ask it to do a push 3 guys down the stack here, and it'll take what had been the guy at slot 3 and stick him in the front. So you can get any one of the guys you have on your list, put it in the front of your directory along the way. Now, there's not much point in doing that when they're really simple names like this, but if you have really big, long paths to mention, that's annoying to CD and then have to type out that big, long path each time. So this is a good way to remember lots of paths and get it. A lot faster. Okay. All right, we're almost being able to find. And let's see, yeah, you already looked at those, and that's probably good enough. Right? When you type SSH, you get on your versions here, it's slightly better there that hopefully will make X work nicer for you. And again, you probably want to do something like that from home if you want your X Windows things to be able to show up on your screens on your Windows files. All right, any shell questions? All right, so that should maybe help you get set up for doing your assignment 1. As I recall, we still have a little bit of lab 7 to still go through. So I got 10 minutes here. Let's look at that. I guess we're not going to get on to chapter 13 today. All right. Yes, you're going to do the same thing for several of these people like home. Carol is what we really had on the old machine here. If I want to be able to get to that directory, you have to adjust it a little bit. And for your own home directories, as we talked about last time, it's going to be mint, home, or Bilbo, whatever, and then your name to get to the appropriate place. All right. All right, so you don't have to worry about creating a new .forward file on your SUSE system because you've got your home directory from Mint, and it had a reasonable .forward file. It also had a reasonable CS470 file, and so on. So as long as you had already had those things set up correctly, you get them all back for free. You got the same home directory. And soon in the other labs, that'll also be true on all the other workstations in the room there. They will also have the ability for you to log in under SUSE and still get to your Mint home directories. All right, and we don't want to do that with the UID 0 accounts, like JC or the Keyroot account and so on. Because those things are a little bit different, right? They have a root -rc startup, and almost certainly that's going to be different than Mint's idea of what root -rc should have, so we really want to keep those things separate. Plus, you don't want to have Mint's actual home directory to be on a different partition than the main partition to begin with. So don't go wild with that. Just to the accounts that I suggested that you make the changes to, not virtually all of them. All right, now you'll notice here, if you try to look at this, Mint's version of Sash, as we had talked about beforehand, right? That was the standalone shell, or the Swiss Army knife shell. Right? With all those nice little built-ins, and it had statically linked libraries so that you could use them. So SUSE does have a thing called Sash, and it does have some of those built-in commands like -mv with your root command and so on. But it uses shared libraries. They wouldn't give you really a standalone shell. To do a file on those things, you know, the difference. All right. Now, again, you need to make sure that I can log in here, etc. And we saw ways to do that back in chapter 1, and of course you want to make sure that you can log into these accounts once you change the password and shadows files appropriately. And as long as you're using the same user ID that you had on your Mint system, on this system here, you'll actually own your directories by default. You won't have any problem with not being able to read into the directory due to the wrong UID. So we're keeping all the UIDs the same so we don't have those sort of headaches to work. All right, then a few things that you should do on your own to begin to set up how this thing looks like. And you should notice quite a difference in beginning with your Mint interface that you have here is quite useful to work with here. And the SUSE one is rather clunky. And indeed, if you go to Ubuntu and use their GNOME 3, it's really bad. But now they've started to put up a Mint interface since Mint got so popular and so surpassed it. You could do Ubuntu with the Mint interface. And that wouldn't be quite so hard. Okay. Right, so down in the lower left corner, you get the little gecko or whatever the thing is there, which also brings up a menu, similar to what Mint had done, kind of where the start button is under the Microsoft Windows here. And you can go through some of the little sub-tabs and things that they have here and follow and look over what's available to you. If you go to the System tab, underneath there is where you will find the terminal. You know, bring up a little black and white terminal for you, and you can type a few commands there and make sure that things are working. All right. Now, when things do go wrong, the place to look for it is in this X-session error file. And that's going to be there whether or not things went wrong or not. It's basically a report of everything that happened as it was trying to bring up X, and then also everything that happened when you exited from the shell. But it may tell you that something is wrong. So if it's not working, if it is working correctly, you can completely ignore that file. But that's where you would look to find any errors. Now, there's a similar one for Mint, only it's X-session errors with an S on the end of it. So it's rather nice that you get to see what happens on one machine in one file and a slightly different file to find out what's happening with the other machine, even though it's all the same home directory. Okay. All right, so we still have that situation here that kind of the default on the Microsoft Windows as well. Doesn't matter where you're moving the mouse, all the input is going into one terminal, whether it's in there or not. You want to change the behavior again to have the focus follow the mouse. So here we talk about how to make that happen. You go to the Windows behavior menu, and that should take care of it here. So just sort of follow things here, it's still kind of leading by hand, so I can use each of these. All right, and then move your mouse around and make sure that the little cursor lights up at the appropriate times as you move your mouse into those windows without having to click. You can also auto hide things here, so that's one of the other little things that I'll be looking for to see if you would be these portions of the portions of the UI. So if you would change the mouse, you need to do that, etc. And to get out, you go to that leave option, and there's 7 or 8 entries in the pop-up menu that comes out. You can shut down the system, but of course you don't want to do that right now. But you can what you choose typically is the logout thing, and then the display menu will come back up if you're back in level 5. Right now, if we were still at run level 3, if you would then start X to get into this, then when you say log out, you really are just shutting down the graphical system, and you'd be back at your black and white big screen here, but still be logged in. So you'd have to sort of actually type log out again. But in our case, when we're at run level 5, when you do shut down that shell, then the display menu